says the figure shows a person and a cow, each radial distance capital D from the point where lighting of current I equals 100 kilo A strike the ground. Okay, so this is a lightning. This is a lightning hit the ground, and then this is D. This is D. Okay, from this point. The current spread through the ground uniformly over the hemisphere. 就是一个半球 center on the strike point. The person's feet are separated by a radial distance delta R pearl. Okay, and then the cow's front and rear hooves are separated by radial distance delta cow. The resistivity of the ground is raw ground to be 100 ohm per meter. Ohm meter. The resistance both across the person between the left and right feet and across the crowd between front and rear hoof is R equals 4 kilo ohm. Okay, 4 kilo ohm is either here and also here. Okay, we assume to be 4 kilo ohm. And then for the ground, okay, for the ground, rho equals 100 ohm meter. Okay, and then distance D from this point to here, and then this is delta cow and this is delta R per. Okay, so A, what is the current I per through the person? Okay, so first of all, we have E equals rho ground times J. Okay, times J. Actually, we have we know I here at this point. Okay, so we will assume that this current will spread through different direction along the hemisphere. 就是它会从这个半球形的球心往所有的方向，这个半球的所有方向去扩散，所以它的电荷密度 ，so its current density will be like this I over 2 pi r square. Okay, 4 pi r square will be the whole surface area of a sphere. So for the surface area of a hemisphere, this will be 2 pi r square. Okay, so delta V, I mean the delta V for the person will be like negative EdR from capital D to D plus delta R. Okay, so which means here we consider the person. So here we have dr. We have the R axis like this. This is 0. This is D. This is D plus delta R person. Okay, I just skip the subscript PR. Okay, so later on we can just put in PR or COW for the cow or for the person. Okay, so E have this expression, so we can put it inside. So we have a negative integration of rho ground and then times I over 2 pi r square and then times dr and then from D to D plus delta R. Okay, I just put in this thing. And then we can move out all the constant. Okay, rho ground times I over 2 pi. Okay, so only dr over r square inside. So from D to D plus delta R. Okay, so in this way, this is r to the negative 2 power. So it is actually rho ground and then I over 2 pi and then times 1 over R evaluate from D to D plus delta R. So it will be 1 over D plus delta R minus 1 over D. Okay, so there is a negative sign somewhere. Okay, so integrating this one, we have a negative sign. So these two negative signs become positive, and then it becomes a 1 over r. Okay, and then you vary from d to this one, and then so it will be 1 over d plus delta r minus 1 over d. Okay, so finally it becomes negative rho ground I over 2 pi, and then times delta r over d, and then times d plus delta r. Okay, we just combine these two fractions to become like this. Yeah. Okay, so for I person, the I person will be delta V, take the absolute value, and then over R, and then over R. So it will be, okay, this expression, rho ground is 100 times I is 100k, 100 times 10 to the third power, and then R will be 4 times 10 to the third power. And then also we have 2 pi, we have 2 pi here, we have 2 pi, and then times delta R pearl. Delta R pearl is 0.5 meter. 0.5 meter, and then d is 60 meter. Okay, 60 and then 60 plus 0.5. Okay, something like this. Okay, so finally we find that I pearl is 0.0548 A. Okay, 54.8 milli A. So the power consumed there will be quite large. You can make it like I pearl square times R. No, not that large, Still okay. I pearl I square, okay. I square 0.05, okay, 0.025. Not too small, not small, not small. Close to a watt, not small, yeah, actually not small. Okay, so this is the P, although it is not asked by this question, but you can also compute this value. Okay, but anyway, for question B, it asks you what is the current I cow through the cow. So we don't need to go through the whole procedure. The I cow is nothing but actually with the same expression. Okay, the only difference is that we just change delta R pearl to delta R cow. Okay, so nothing different. Okay, so it becomes 100 times 100 times 10 to the third power, and then here we also have 4 times 10 to the third power, and then 2 pi, and then here R delta R cow is 1.5, so this is 1.5 over 60 plus 1.5. Okay, so the value is 0.162 A. Okay, so like this. Okay, so comparing this one and this one, okay, you can see, oh, this one is larger, this one is larger. Okay, so you can also expect, oh, this power consumption by the cow is even larger, much larger. Okay, so this one 0.16, this one is 0.05. Okay, 3 times larger. So the power will be almost 10 times larger, 10 times larger power consumed by the cow from here to here, from here to here. Okay, so 所以这个例题的教训我们是什么？打雷的时候我们要立正嘛。当然有时候我们要趴下来嘛，趴下来我们不要当最高点，不要当这个点啊。但是如果不是打到你的话，就不要把脚叉开。Okay. Yeah, so here we have another additional example. So it said what is the current in a wire of radius r if the magnitude of the current density is given by this one, JA equals this one, and J0 is this value. Okay, so here we just let you familiar with how to do the double integration. So integration of JADA, integration of JADA. Originally should be the J vector dotted with DA vector. Okay, but here we already assume that DA and the J points to the same direction. So it becomes JA times DA. Okay, so this is the expression. So we have an integration of JA is J0 times small r over capital R, and then dA, if you still remember, dr d theta. Okay, so dr should be from 0 to capital R, and then theta should be 0 to 2 pi for a whole circle, in the polar coordinate. Okay, so this one becomes integration of, or maybe I just put J0 over R in the front, and then we have integration of R squared dr, and then from 0 to R, and then times integration of d theta from 0 to 2 pi. Okay, so it becomes J0 over R times R cubed over 3 times 2 pi. So it turns out to be 2 pi r squared over 3 multiplied by J0. Okay, so now we can plug in the number 2 pi over 3, and then times r is this one, 3.4 times 10 to negative third power quantity squared times 5.5 times 10 to the fourth power. So this is 1.338. So the question here is only, okay, this current density is not a constant. It is related to the radial distance. So we need to use the integration to find the total current across this wire. Okay, so this is just the first question, and then for the second one, the only difference is that here JB is something like this. All the other things are the same, so it first asks you what is the current for this situation. So IB will be integration of JB dA. Okay, so the same, and then we have an integration. JB is J0 1 minus R over capital R d theta, and then integrate from 0 to capital R, theta is from 0 to 2 pi. Okay, so similarly we have J0 over R, and then here a little bit different, which is R times R minus R dr from 0 to capital R. Okay. Yeah. And then we have an integration of d theta from 0 to 2 pi. Okay, so J0 over R here. Okay, so for the first one, R times capital R. R times capital R. So if you integrate that, it becomes R times small r squared over 2. And then we evaluate from 0 to R, it becomes R cubed over 2. R cubed over 2. Yeah, because this is the only variable for the first term. And then for the second term, it is R squared. So the integration becomes R cubed over 3. So it is R cubed over 3. Okay, so for this one, okay, becomes something like this. Okay, and then times 2 pi. So in this case, it is actually okay, pi r square J0 over 3. Okay, so here we put in the values, which is pi over 3 and then 3.4 times 10 to negative third power quantity square times 5.5 times 10 to the fourth power. So this is 0.6678. So which is half of the previous case. So in question 3, it asks you which function maximizes the current density near the wire surface. And of course the answer is for the JA. This is for question B, and then for question C, JA maximizes the current density near the surface, because it is very clear. JA, when we take R equals to capital R, for JA it is J0, but for JB, if we take R equals to capital R, 1 minus capital R is 0. Okay, so JB and R equals to capital R will be 0. So it actually minimizes the current density near the surface. Okay, any questions? Okay, so here we still have the final one to finish this chapter off. Okay, so here it says wire section 1 of diameter D1, okay, and wire section 2 of diameter D2 connected by a taper section. The wire is copper and carry a current. Assume that the current is uniformly distributed across any cross-section area through the wire's width. The electric potential change V along the length L equals to M shown in section 2 is 10 microvolt. 10 microvolt for this part. 10 microvolt for this part. The number of charge carrier per unit volume is 8.49 times 10 to 28 per meter cube. So what is the drift speed of the conduction electrons in section 1? Conduction electron in section 1. Okay, and then we know the rho for the copper is this value. Okay, so first of all, we would like to calculate E2 equals V over L. V over L. Okay, actually the L is a known value. L is 2 meter. L is 2 meter. And then V is 10 microvolt. 10 microvolt. So this is 10 times 10 to negative 6 over L. Over L is 2 meter. Okay, so this is 5 microvolt per meter. 5 microvolt per meter. This is E2. E2. Okay, so in that sense, we can calculate J2 will be E2 over rho. E2 over rho. So we make use of the vector form of the Ohm's law. So this is 5 times 10 to negative 6 over rho is 1.69 times 10 to negative 8. So this is 296 A per meter squared. Okay, so now we can have an equation like J1A1, okay, will be the I for the first part, which should be equal to the J2A2. Okay, so the current, okay, go through the path should be the same. Okay, which means if we cut a cross-section area here, okay, so here we consider the I, and the I here should be the same. The I for both surface should be the same, and for both case I equals JA. Okay, so for part 1 for section 1, J1A1, for section 2, J2A2. Okay, so these two should be the same, and thus we can calculate J1. Okay, because finally we would like to find the drift speed in section 1. Okay, so when we think about what formula with the drift speed, it probably be the J equals NE times BD. Okay, so we will be able to find drift speed with that formula. So that's why we would like to calculate J1. Okay, so J1 will be J2 times A2 over A1. A2 over A1. So J2 is 296 A per meter squared. And then A2, okay, for A2, okay, both of them are circle, the cross-section are circle. So the diameter here, D1 equals 4R, and then D2 equals 2R. So which means the radius R1 will be 2R, R2 will be R. Okay, something like this. So in that sense, A2 will be pi R square. So pi R square. For A1 will be 4 pi R square. 4 pi R square. Okay. So J1 will be 74 A per meter square. And finally, we can use for VD equals J1 over NE. Okay, and then we plug in the number. 74 over N is, where is N? N is here. Okay, 8.49 times 10 to the 28th. 10 to the 28th, and then times 1.6 times 10 to negative 19. Okay, so this is 5.44 times 10 to negative 9 meter per square. Okay.